On Tuesday, April 15th at 10 a.m. Eastern, join us for the Optica Online Industry Meeting focused on precision agriculture and food safety. This 90-minute session will explore how optics and photonics are transforming the global food system from soil and crop monitoring to livestock diagnostics, food processing, and alternative protein production. This is not a webinar, this is a live industry matchmaking session. The organizations represented by our invited speakers are actively seeking technology partners. If your company develops solutions in photonics like imaging, sensing, laser systems, integrated optics, this is your opportunity to connect directly with end users and integrators exploring agri-food applications. Do you know who will be in the room? Number 1, Unilever, driving digital transformation across its global food supply chains, including quality inspection systems using optical sensors and imaging. Number 2, One Planet Research Center, developing advanced photonics integrated platforms for real-time food processing analytics using AI and spectroscopy. Number 3, Agent, deploying autonomous solar-powered field robots equipped with computer vision and multispectral cameras for regenerative agriculture. Number 4, Arvalis, France's leading agronomic R&D institute, leveraging hyperspectral imaging, drone-based LiDAR, and near-infrared sensors for precision crop management. Number 5, Mozambique, innovating in cultivated meat production with non-invasive, optically monitored bioreactors to optimize cell culture environments. And number 6, Lavi, offering handheld spectrometry tools for real-time raw milk quality analysis using optical absorption and scattering techniques. This meeting is designed to connect photonics innovators with real-world challenges and buyers in the agri-food space. Whether you work in spectroscopy, fiber optic sensing, imaging systems, or integrated photonic devices, this is your gateway into a fast-emerging high-impact application area. Register now and position your company at the forefront of sustainable food systems powered by photonics.
Agriculture. It is easy to organize events for us in fiber optics for data and telecom. We're in contact with the data center to share the demands with us. Today we are out of our comfort zone. Today we are talking to farmers, we are talking to direct customers, and we are talking to you, the integrators of photonics technology who can satisfy the need for those farmers who are going to make a difference in the future. In this hour and a half, we're going to talk from fake hamburgers all the way to the next generation hyperspectral imaging chips, and we're going to monitor crops all over the world. My name is Jose Porto. I'm the Chief Technology Officer of Optica, and I'm really happy to today lead a fantastic team of experts from Optica who have put together one of the strongest agendas I have ever seen in the food or in the field of agri-food. I would like to start by saying that Optica is an industry network and an academic society, and our job is to, of course, strengthen the communication link between our members and make sure that we connect with the partners, suppliers, customers, investors, and talent. And for those of you who are wondering if I'm reading, I'm not reading. I'm just saying this from the bottom of my heart. Today we talk about food industry, and we had the following integrators in the room: Unilever, One Planet, Agent, Arvalis, and Mozambique. This is a part of our agenda. We have been having these meetings every 2 weeks, and the feedback from the industry has been overwhelming. We need your feedback, but we also need you to join as a corporate member. If you want us to do what we do, if you want us to continue having a job here, you need to become a corporate member. For those of you who are not a corporate member, optica.org/join corporate, join right now, and you make me and my team extremely happy. Next week, no, in 2 weeks, we have a quantum internet event, and wait a minute, on the 6th of May, gas and liquid sensing. Write that date down. 6th of May, gas and liquid sensing. We're having a spectacular event on that day. As spectacular as the event that we have today. As I said before, we are a network association. We provide access to our network. We provide market reports. We provide events all around the world. And of course, lots of engagement opportunities. If you have seen LinkedIn, you have seen our videos or interviews, you need to be part of our network. Please join us. We are now the largest association in terms of individual and corporate members. We want to continue that way, but most important, we want to continue providing individual benefits to each and one of you. this QR code links you to our industry library. We have the largest database of market reports from any other association. If you are looking for the next generation laser technology, data transceivers, cameras, detectors, we have all the market reports here. Please make sure if you're a member, you download all our content. If you're not a member, what are you waiting for? That meeting is also still on YouTube. So let me say hello to the YouTubers in the world. So, hello, YouTubers in the world. If you are not in the Zoom room, you can follow the meeting live in YouTube. If you have any questions, write them in the chat and I will read them in the room so we make sure they are answered by the experts. And of course, this is also valid for the people here with me in the Zoom room. This is not a webinar. You just came here to just listen to people. Maybe you can go to YouTube. Here you are to communicate your technology to the integrators from all over the world, from the Netherlands all the way to Canada, that we have brought to you. And with this, I would like to say that today is an incredible day. Because not every day we have in the room one of the most important companies in the world. A company that has made a difference in the way that we eat, in the way that we clean ourselves, and in the way that we monitor every single thing that touches our body. I'm talking about a company that for the first time appears in Optica, and of course, I hope for many, many more times. Michael van der Stappen, thank you very much for bringing your brother to Optica. Of everyone, what incredible thousand people are watching you. The floor is yours.
Thank you, thank you. Ms. Welk, very nice introduction. Just checking, is the sound good? Because for me the sound so far was a little bit wobbly.
Your sound is crystal clear, but I'm
okay.
it's out of mine.
I could follow you, but it was a bit bathed up sound here and there, but hopefully it's clear. So thanks for this very kind introduction. I feel honored to be in this forum because speaking to some of the organizing beforehand, I'm not a technical expert in the photonics or related areas, but I hope I can bring a perspective from the food industry on why technologies from this domain definitely can bring many benefits. So let me kick in and share my presentation. That's probably the best start. Share. There we go. Anybody on screen? You should be able to see it now, right?
Clear.
All good?
Yes.
Good. So my name is Michel van der Stappen. I'm based in Wageningen in the campus, but working for Unilever. I'm speaking today on behalf of Unilever as a major food company, but also in other industries, and in this particular day, mostly on the food side, but also we'll mention and speak on behalf of what we call the Next Food Collective, which is basically a collection of partnership of similar companies in the domain like Unilever, but also a Knowledge Institute in the Netherlands. So trying to take a bit more of a wider industry perspective as well. So just very briefly about me and what I'm representing. Worked many years in corporate R&D, background in chemical engineering, but both basically worked my life in foods R&D in very many different roles. Lately, as in the last few years, more and more delving into how digital technologies can sort of revolutionize foods. And then I basically in two ways. I mean, the way we manufacture, process foods, etc., which I will talk a little bit more today, but definitely also in the way we develop foods in R&D, how we do the whole R&D process basically in foods from start to finish, where there's a lot that can be changed and improved as well. And today I hope to sketch a little bit the why it's important that new technologies, like many of you will be involved with, can benefit this industry. And then a little bit on what kind of domains and needs there primarily are. So I won't talk so much about solutions, but mostly about the questions and the needs to kick off. But I'm sure many speakers after me will talk a lot more about exciting solutions as well. So that's the purpose. Before we zoom in, let's not forget about this. For those working in foods, it's probably obvious, but also if you take a wider society, why is it important that system changes occur in this whole food industry? Some of these are on this chart, right? Although we have a huge and in a way very efficient food system globally developed across many countries, many generations over time. At the same time, it's not very effective in achieving its main goals, you could argue, from whether that's a health goal for society or shocking statistics that if you look at the whole chain of foods, a third of what is produced in the end doesn't reach us as consumers in terms of food, but is wasted somewhere down the chain. But also, of course, its impact on climate in the different ways that come from food. So before I go in, when I talk about food, and in this particular case, I will mostly zoom on what I would call food processing or the manufacturing. So you could say the post-field activities, or at least a large part of the chain that covers that. Typically, I would say if you look at the whole industry, there's two major steps you could say in that. And interestingly, I find if you look at the industry, you also find different players, different companies typically operating in either of them. So there's you could say a big industry turning crops as produced in the fields, and I know we will hear more exciting things about that part of the food chain later as well. I won't cover that here. But turning that into, let's say, ingredients of different nature, whether these are highly refined ingredients or just relatively simply processed ingredients from the crops. There's basically a vast industry globally dealing with that. And then interestingly, there's another part of the whole chain that takes those ingredients and turns them into consumer products in very different ways. Of course, if you zoom out and look at the whole chain, there's also a more direct chain from field to consumers. But again, I will cover that less. So I'm mostly focused on that processing part. And then in particular, for example, with a company like Unilever, we operate in this space on the right. But I think what I will say, as in terms of needs, broadly speaking, would be valid for both those big steps. So where are the needs coming from? Zooming a bit more into the area of today, it's basically related, in my view, to that digitization I was talking about earlier. I'm interested in, and you see the industry, like all industries, I would argue probably at the moment, the food industry also is digitizing. Mostly that's expressed as some kind of version of a digital twin development. I think the state of that, I would argue, in food industries varies a lot, from almost not there or completely absent to quite sophisticated. It very much depends where you go, how much has been invested. But if I would broadly try to summarize where are some of the main challenges, and in particular today, the one highlighted in yellow, I think is an important one to zoom in. But it's not easy to develop digital twins. It's easy to talk about it. It's easy to paint a nice picture or create a fancy video. But then to do it on an existing food industry is a lot of work. And business case validation to start with can be non-trivial or a lot of work to estimate, to unlock the funds to invest. But if you then want to do it and agree to build digital twins, I would say two typical challenges you face with in the industry is, first of all, that the skills of the workforce, including R&D teams, but certainly factory teams, to deal with this more sophisticated digital twins is not necessarily there. But also very importantly, and that's the area I want to zoom into most today, is that when you then start taking the signals and the data that comes from food processing plants, either they're very difficult to get because equipment can sometimes be quite old and not necessarily geared up for digitization. But if it is, it would typically give you lots of operational data about your equipment, things like temperature, pressure, rotor speed, you name it, but very little information about the quality of the products or the materials you're actually producing. So sensors to say something meaningful about what is this product I'm dealing with, what is this ingredient I'm dealing with, what can I measure about the quality, any attribute of quality that tells me something directly is rare in my view to find in the typical food factory. So this is where there's a big need, because what you really want to do with those digital twins is a range of things, but maybe these are not in particular order. But if I would tell the story, I would say in the end, what you want to do is achieve a better and more continuous control of the product quality you're making. So the second bullet on this point, which is really critical to have therefore meaningful information about what is that product quality I'm measuring. You also want to do that much more digitized, because if you look at the third bullet, it's I would say common practice for almost any food factory that it never makes one or two products. It always makes a whole portfolio of products. So at the end of the day, you're continuously switching between making different products in a similar factory setup, which definitely increases the need for more control and more measurement of what you're making. Because otherwise you end up with what's mentioned here, number 1 and number 4, too much. Yeah, and accepting there's a degree of that always necessary. So when you switch over between different products, there's always cleaning of the lines. Depending what you're making, these requirements can be super stringent. You know, for example, if you think about allergen control in food factories, which is probably one of the, together with microbiology, one of the key safety elements that typical food factories face with, requirements to make sure that there's no allergen crossovers, things like that can be super stringent, which effectively means that a typical food factory making, I don't know, mayonnaise products, various different formulations as you will find in the supermarket, can end up spending a lot of its time cleaning rather than making products, which of course is not what you want. And then last but not least, wastewater will happen. You try to minimize that, of course, but when you are treating it, there's also definitely a lot of opportunities for better control and measurement in that area. So typically there's a big need, I would say, for all those digital twin and optimization use cases. But again, time and time again, you find that if you want to build them, at the moment, it's very difficult to get sensor data about the ingredients and the products you're actually making in these factories. Maybe one word to not forget, depends, of course, a little bit on the type of product or type of industry you look at. But certainly if you look at the consumer goods part, which I'm working in mostly for foods, a factory, yes, it's making the products, but if you would walk into an average factory, most of what you see actually is the packing and the filling lines. Yeah, so in the end, the product is typically made in bulk, and then it's filled into a number of small units as you would typically buy, all of you as a consumer in the supermarket. And I think it's often at the interface between those two lines that also there's a critical control point that needs to be watched, right? Because that's where the final consumer unit is assembled, and control of that is also a huge opportunity, again requiring information about, for example, the product quality you're making. So yeah, I hope that sort of gives a bit of sketch. So for me, the bottom line is I try to summarize on this chart. Again, as warned, I'm not giving a lot of solutions, but more questions and things to address. There is a huge need and therefore a huge opportunity, I think, for new sensors related to food product quality in a broader sense in the food industry. What do we need, or what are sort of the constraints or requirements to look at? Yes, ideally they work in line, obviously. I would say if that's maybe a step too far from, depending where technology is, even something that works very well or very rapidly and very easily at line So simple to use in the factory by the operators. Or even as an in-between step, something that is super rapid and offline is already an improvement. Because the reality is that many quality control, quality assurance measurements today are really done by taking a sample, taking it to a lab. Sometimes that lab's on site, sometimes that's even off site, and then doing the analysis. So anything that moves that closer and more continuously at a line is an improvement. Of course, the inline is always the holy grail to go for at the end of the day. It's something and technologies that measure something about the product quality, right? So not trivial things like temperature or pressure. I mean, they're important to also monitor. But if that's the only thing we can monitor, then in the end you will end up with relatively black box data models to control your digital twin, which may say something about the quality. If you have enough data, for sure, you can get a long way, but you're never really sure. And in the end, food is about sensory, appearance, structure, color. These attributes are the ones that you would like to sort of assess in terms of quality attributes. But also, of course, composition-related ingredients. Certainly for more functional products, so with a sort of functional nutrient benefit, the specific levels of specific ingredients can be critical to be monitored, can be regulated, even though in many cases to be controlled. Lex and I, and Lex will talk after me, we sometimes been dreaming about, okay, could you even go as far as detecting allergens? Well, that could be maybe on the horizon, because you're talking about sort of very small amounts and highly sensitivity that you would need. But contaminants in the broader sense, so either the composition you aim for from a positive intent in what you make, or something that you don't want in your products to be monitored directly. The third bullet, the final solution at the end of the day, if it wants to find commercial application, will have to be relatively simple and robust. That is because food factories are not the highest tech industries we have, right? There can be quite basic industries that don't necessarily have a huge technical team on board to keep everything going. So whatever operates in that environment needs to be robust. It needs to be relatively simple to operate. You wouldn't have a photonics or an AI expert necessarily in your factory to deal with what's happening there. And of course, affordable. I think there is an opportunity also during development phase, definitely look at pilot plants. Like I said earlier, digitization in the food industry is happening in the factories. Equally, it's happening in how we develop foods in R&D, where pilot plants, of course, play a key role. So as an in-between step during the development, I think we shouldn't forget about that space as well. So let me leave it there, but hopefully that gives a bit of a sense and a feel for what I would say is the kind of final application in a typical consumer goods food industry that we would be looking for.
Yeah, thank you so much, Michelle, because you represent one of the biggest company that is the end user, getting all the passing through all the food cycle, so to get it finally product, which is what we get at home. But I'm very curious, because you have this ambition combining the digital twins with adaptive processes control. So my question to you is that the current sensor resolution and update rates that we have in the market right now, is it going to meet the demands for the predictive models that you need?
Well, yes and no, I would say. If you look at the sensors and data that can currently be measured and are measured, where where there's a degree of investment in this happening, you
Mhm.
know, those I would say yes. So yeah, the typical operational parameters I mentioned, temperature, pressure, equipment related data, vision related data. I would broadly say that for most processes, the frequency and resolution with which they can measure that attribute is okay. I don't see major barriers there. There's some very high-speed lines, certainly high-speed packing lines that could be difficult, but I don't think food industry equipment would typically be at a too high end for those type of sensors around. But the problem is that it's not so much a measure of frequency. We hardly can measure anything at the moment directly about product quality, right?
Yeah.
So
Yeah.
so really most of what goes on is taking a sample and doing a measurement. Well, frequency and whatever that is at best one a day or one an hour or whatever. It's nothing even close to operating speeds for control. So the key bottleneck for me is something that mentions something meaningful in terms of product quality. And
Yeah.
even a relatively slow response rate of that would be a big step forward compared to having nothing, right?
Mhm. Yeah, absolutely. So, the other thing is like, you know, what sensing modality is more promising? So, is it going to be, hyperspectral, dielectric, NIR? So, what's your prediction?
Well, there I'm not, that's not my area of expertise, if you want. Which technology, so to speak, would be the more useful?
Yeah. So,
I think there's probably, if you zoom out across the industry, there's probably room for multiple technology platforms, I would think. And in particular, Lex and I have been discussing that as well. I mean, ideally, you can also look at platforms that work broader than in one particular product or one particular industry, right? Because then you
yeah,
can leverage
yeah, and
scale.
this,
But
yeah,
you know,
this, yeah,
Actually,
absolutely.
we have a couple of very good questions for you. And Michel, once again, thank you so much. It must sound much better now,
yeah.
like really good sound. I would like to acknowledge the headset brand, which I just switched. There is a question coming all the way from Intel. Ranjit Kumar, are you with us? Could you ask the question yourself? If not, maybe he has the brand of headset he had before. Let me read the question for you.
Stop
So
sharing.
the question is, none of the highly processed ingredients are good for health. So how do you perceive for food industry business and respective government regulations? The fact that highly processed food are not good for health, how is it perceived by Unilever, and how can we switch this mentality?
Yeah, I think this is drifting a bit away from the topic of today, right? I mean, I think you open a big box there of discussions, which frankly I'm not an expert in. I mean, many of my nutrition science great colleagues talk about that, but I think in the end, food is processed, right? When food reaches consumers, there is always degrees of processing happening between the field and growing of crops, and ultimately what you see. So I think that needs to be better managed, better monitored, better controlled. Frankly, the whole debate whether processed or ultra-processed foods, as many people call it, is good or bad for your health by definition, I think is a topic for another seminar.
Thank you very much. But indeed, let's stay with the topics that we are experts on. And the purpose of this meeting, Michel, is that you meet people that can help further the business. You talk about pilot plants. I want to talk about pilot lines. When it comes to food safety, in photonics, we can do hyperspectral imaging, we can do laser-induced fluorescence, we can do LiDAR and put them in drones, we can use quantum cascade lasers monitoring the mid-infrared, we can do many things. But with photonics, we can do very little unless we can make products. So, Michiel, I would like to introduce you a European pilot line for manufacturing of those products that is being set by Hamamatsu. Andrei Voloshin, thank you very much for coming to this meeting on agri-food. It is great to have you with us. Could you tell us in a few words, what is the pilot line that Hamamatsu Photonics is setting up?
Yeah. Thank you, Jose, for introduction. Thank you, Michael, for very nice talk. So it really helps to understand the struggle of your current industry. And we at Photonics are really experts with photonic components. We know everything about lasers, fibers, lenses, photodetectors, but we usually need experts of the end user application like you. And then like knowing your needs, we can build a very custom module for you, which will do the job which is really needed for your application. So with our Hamamatsu Photonics pilot line, we take concepts of photonic models of our customers, first doing some prototyping and experiments, proof of concepts, and then doing mass manufacturing in Japan. So we are not as like photonic pilot lines in Europe, doing only small volumes. So our pilot line starts with high volume as the last step of our interaction. And we are really happy to work with customers in the food industry because it's really a nice match of our expertise in photonics and your applications. And for example, there could be really many solutions that you said, hyperspectral imaging or X-ray imaging, or for example, fluorescence imaging. So we can try different approaches and find what really works for you and then start mass manufacturing of these devices.
You mean a pilot line to make the photonic device, right? In this case. Yes.
Correct.
Okay. Yeah.
And Michiel, what we're going to do is we're going to introduce it to the next speaker, and then we're going to see how the three of us can make something working together. We're going to go to a beautiful city in the Netherlands, our favorite country today. We're going to go to Wageningen. For those of you who have never been there, you have to go there. And when you go there, you have to see the One Planet Research Center, one of the best efforts made in Europe, I would say the world, of bringing new photonics or new technologies in general to the agriculture sector. It is an honor to welcome our second speaker today, now with proper voice, with proper audio, Lex Oosterberg. Goedemiddag. Thank you very much for being with us today. The floor and the attention of the world is yours.
Hello, good morning. Yeah, thank you for your invitation, and I'm happy to present here. Can you please share my presentation?
It is coming. Here it is.
Yeah, my name is Lex Oosterveld. I'm from One Planet Research Center, and we are an innovation center for chip and digital technology for agri-food and health applications. And we are a collaboration between Nanotechnology Center IMEC and two Dutch universities, Wageningen University and Radboud University. And today I will give an example of one of the sensors that we are working on, that we are developing, and that's a laser-based rheology for the assessment of gelation. And this is work of my colleagues, Gabriela Follette-Masson and Matthijs van Kilsdom, but I will present it today. Can you go to the next slide, please?
Next slide, please.
Yeah, so what we try to do is develop a real-time process control by using sensors and data solutions. And basically, this is what food processing 4.0 denotes. So with these sensors and data science, we want to improve the quality of food and the safety of processed food products, reduce production costs and time, and save energy and resources, as well as diminish food loss and food waste. And for this we use sensors, software, connectivity, robotics, and data analytics. And I think it's now the right time for a revolution regarding food process 4.0, because there is a lot of development on chip-based sensors, for instance, based on photonic integrated circuits, but also the development of cloud computing and the development in data analytics and AI is now really booming. And this combination will really revolutionize food processing. So what are the reasons that you want to sense in food? Well, that's for process control, but also for food safety, also regarding to labeling and also regarding to sensing. Next slide, please. So in our food program, we focus on nanotechnology solutions for sustainable food processing. And this is a combination of the development of novel sensing tools to monitor food processing, but also linking these sensing solutions to data science and to develop chemometrics, digital twin simulations, and predictions. And the reason why we want to do it is that we enable real-time process control of food process streams. And we focus on novel protein production and also side stream valorization. Next slide, please. Yeah, food proteins are, of course, very important for our diet. They're an essential part, and the reason for this is that on one hand they ensure the nutritional value of the proteins based on the amino acid composition, but also they have a function in food. And when you want to replace food, proteins, you need to consider both the nutritional values and the functional properties of the food. And this is important in relation to the protein transition, where animal proteins are being replaced for plant proteins or emerging proteins. Because animal proteins require a lot of resources compared to plant resources, plant proteins and upcoming protein sources. Next slide, please. Yeah, and where the food industry is now really struggling with is that if you want to replace these animal proteins with, for instance, plant proteins, they find that the functional properties of these plant proteins, they vary quite a bit based on where they come from, when they are produced, but also what kind of processing they have undergone. And nowadays, if you want to compensate for this, you have to do expensive and time-demanding techniques. For instance, if you look at functionality, rotational rheology is being used. And currently that's being done offline in a laboratory, and it takes a couple of hours. And if you also want to do the data science on top of that, often you have the result maybe within a day. But our objective is to go towards inline measurement of the functionality of proteins and also high throughput measurement of these proteins using optical techniques. And the advantage of this is that in this way you can control your process and optimize your process, but also decrease food waste and use your resources in a better way. Next slide, please. Yes, so we specifically look at the gelation process of protein ingredients. And for this, we use an optical technique, laser speckle sensing, to investigate the gelling properties of these proteins. And the way this works is that the particles in the food product, they will have a different motion when they are in the gelated product compared to when there is no gelation. If there is gelation, then the particles are hindered and they cannot move as quickly as in a product which is not gelated. Well, this is something that you can measure using these laser speckle patterns. And by understanding the movement of these particles in these complex systems, you can calculate the viscoelastic properties of this of your food product. So you can understand how your proteins function in your food product. And this laser speckle pattern is directly related to the particle motions. So this is an ideal way to investigate gelation. Next slide, please. So we are working on this technology, and this technology has been around already for a long time. This is diffusive wave spectroscopy. This is being used to track these speckle changes to investigate sample dynamics. However, this is still an offline technique. So we are working on translating this to a sensor which can be used inline. And here on the right side of the picture, you see a graph of some work that we did with various concentrations of proteins. The blue line is a very low concentration, and the red line is a concentration of 1.5% of gelatin. And what you see here, we measured this with using laser speckle sensing, and you see that at the low concentrations, that the curves are still very much on the right side of the graph. But when the sample starts to gelate, you see that the curves really change and move towards the left, towards the right side of the graph. And in this way, you can really track your gelation process by measuring these laser speckle patterns. And we are now working on making this into a device which is suitable for inline measurement. Can you go to the next slide? Yeah, so where we focus on, this is one of the example of that we focus on real-time process monitoring and control. Well, this was an example of measuring the texture of a food product. And this enables feed-forward and feedback process control. And this has a number of advantages. It results in earlier batch release, increased quality, reduction of resources, energy, raw materials, and it allows for less pure ingredients. And this also touches on the question which was asked before if you can monitor your process better and if you can really have real-time process control, you can this allows for less pure ingredients, but also for less harsh processing conditions. So in this way, basically your ultra-processed food will be a little bit less ultra-processed, and also you can use less pure ingredients, which can be an advantage because of the nutritional aspects. Okay, this was my presentation. Thank you for your attention. Do you have any questions?
Thank you so much, Lex. This is actually, this is actually very good because it's a new wave. And in coming into the industry 4.0, so the food industry couldn't be behind. Absolutely no. And let's start for one of the things. So I'm very curious, like, how do you calibrate the speckle pattern to correlate with the standard viscoelastic model in complex food matrices?
Actually, we use a combination of laser techniques, but I cannot explain that because we are still filing a patent in this direction. So I cannot explain the,
Don't worry, Lex, because finding laser technology is our job. So allow me to bring somebody to the room here. Lex is meeting for connecting companies, and there's a company that I love. I love every company, so one we particularly love. It's called PicoQuant. Evangelos, thank you very much for joining our meeting today. You develop lasers and LEDs for many applications. I'm a quantum geek, so of course you have helped me a lot in my career. What can you do in the agriculture market?
Yeah, thanks for giving me the time, Jose. I feel a little bit of an outsider, but I think this is exactly the scope of this kind of meeting. So PicoQuant, you know us from Vandum. You know us from the lasers and the LED and the detector side. You see behind me in the background some cells. So we're very active also in life science, doing spectroscopy, fluorescence spectroscopy, and in particularly we are dealing with a parameter of fluorescence emission which is called fluorescence lifetime that provides some advantages in comparison to simple intensity images. We have lasers in the whole spectrum from UV to the infrared. We are open to discuss OEM deals, so customizing our lasers and our LEDs. I have to admit that until very recently, the big percentage of our customers coming from academia and from the research institutes, but we're very open and start dealing with industry-related problems. So you can take this as an offer. If you think that fluorescence spectroscopy or hyperspectral imaging in general is of your interest, please reach out to us. You can write an email.
Evangelos,
and-
the fact that your market segment is academic is about to change because you are joining Optica, and it is our job to connect with
Exactly.
particular customers. And one of them is the company Mosa Meat. Dhruv, you have a very important question that both Evangelos and Lex can answer. Could you voice the question yourself?
Sure. Thanks for a great talk, Lex. I was just wondering, as a complete novice in the field of optics, photonics, whatever, how do you do the speckles need to be sort of labeled particles that you need to track, or do you track sort of unlabeled particles?
No, basically it's analysis of your of the scattering pattern of your laser, and I think the basis of the technique is already known for a long time, and there are already offline laboratory equipment based on that principle, but we are translating this to an inline measurement, and for that some more work is needed than only doing the laser speckles.
Dhruv, actually, there is a lot of effort, in particular in the Netherlands, on next generation FTIR and actually miniaturization of the handhelds. I would like to have a shout out for the company Praxasense in Delft. They're making a huge development on this. Lex, allow me to cross the circle. We start with Michiel, and now we go to you, and now we go back to Andre. Andre, you were wondering if this is a commercial device. My question to Lex is this a commercial device? And second, to Andre, how can you help here? Lex.
Yeah, the question is to me first. Yeah,
Yes.
this is a device which we are developing, which will be commercialized in the end, but we are still in the R&D phase.
So you have to go to pilot phase first and then commercialization phase. Andre, how can you help?
Yeah, so we definitely can help you with, first of all, making your manufacturable prototype when your R&D is ready. And I'm really curious. So, are you targeting like are you facing some like price constraints? So, when you develop this thing, you want to make it low cost, or you can like handle higher cost of laser systems, because that is like really nice performance and customers will be happy to pay for it.
Yeah, of course, the price always needs to be as low as possible. But I think for this type of equipment, it replaces commercial offline laboratory systems, and it still has a lot of advantages. So, and these offline laboratory systems are in the area of $50,000. So these are the price point that the sensor solution would cost.
The two of you will talk offline. Lex, you mentioned generative AI in your presentation. Get ready for something really cool here. We're going to go to a company called Agent, and we're going to use robots to remove weeds using AI. That's how cool we can get. Kenny Lee, thank you very much for joining this meeting. What do you think so far?
Oh, this is pretty cool. Thank you, everybody. My name is Kenny Lee. I am CEO and co-founder of iGen, and we're based in the US. Our HQ, our headquarters is in Redmond, Washington, the state of Washington, but we operate out of the Midwest and also California. So let me talk about what we do and why. If you look at the tech stack in terms of sensing, you have satellites in space, we got drones flying around, and then we got fixed sensors in the ground. And each of these have unique advantages in terms of sensing. But what we believe is fundamentally missing is a tech stack layer where you essentially have a mule or donkey that is self-powered, that does not need food, and that's constantly roaming the land and collecting data and converting that into action. And so with this thesis, we created what we call terrestrial rovers. And so as you can imagine, the use cases are varied and vast. We could be working on a lot of different things, but the first that we're working on is agriculture. And I think Michelle mentioned this, but it's quarter of our global emissions and it's 40% of our land use. A lot of our human land is used to grow food. And I know there's a lot of advances in indoor agriculture around the world, but at least here in the US, vast majority, if not all, of our food crop production comes from outdoors, which is why we're excited about this. So what we're doing with this, the platform first is we've built a 100% solar-powered autonomous weeding robot. And what we mean by 100% solar-powered is that we've proven out during the course of the entire life of the growing season that you do not need to swap out batteries, refuel, or even require any power recharging infrastructure on the farm. So what it does is all the way from planting all the way to harvesting, it lives on the farm the whole entire growing season, which is what we proved out this last growing season. And it's all edge AI. It does not require cloud connectivity to do the job that we're asking it to do. And it carries around sensors and actuators, in this case, arms with blades at the end of it, which is what we call a hoe, to remove the weeds. So just to give you a sense of kind of scale, we can ship it to you in a crate like that, and it gets deployed on a farm like this. This is just a small quarter section. This was just taken a few days ago in Central Valley, California. Why weeds? I don't want to kind of get into it too deeply, but weeds are one of the biggest problems in terms of crop protection, and that's the reason why we till the soil, and we also spray chemicals like glyphosate. And it is at the nexus of how we produce food here on planet Earth. Farmers are facing some major challenges, manual labor shortages, at least here in the US, with policy and some of the demands. It's waning. And there's also what we call herbicide resistance, where chemistry is not responding as well as it used to. Where weeds are not dying as effectively as it used to. And then from a consumer perspective, I think we all know this. Should we have a choice between fruits and veggies that were sprayed with chemicals or not sprayed with chemicals? I think we would all pick up the product without chemicals if we're feeding it to our kids, and if the price was at parity, right? Weeding is a big market. But let me show you exactly how we do it. So we have RGB cameras. We're not using any LiDARs. We're not using any fancy sensors yet, because we don't need to. Because I think Lex mentioned this, but we're trying to keep the cost as low as possible to the farmers. And so unless we feel that it's really solving a problem that we've identified, which is a burning platform for the growers and the farmers, we won't add those sensors. So in this case, we're using edge AI with quantized models, which is hyper efficient AI models. We built our own foundational model for this, and we're detecting what's a crop and what's a weed. And what's really unique about us is that we really mimic how humans would go through the field and weed. Even though it is mechanized with motors, that sweeping motion is how humans would go through and remove small weeds, lightly disturbed, the top half an inch of soil, just to get the little baby weeds out of the way. Or if it's a bigger weed, then you would actually go through and strike and remove the big weeds out. And that's how our robots operate. It wants to be out there as early as possible and continuously throughout the entire growing season. We built about 50 of these robots last year, and we have over 10,000 hours of autonomous operations. What that means is that we left it out there and we would monitor them remotely, which was a huge success for us. So we had an operation center where we would watch these remotely on TV, and we make sure that nothing's going sideways for the growers. Okay. What's interesting above and beyond just the weed control, weeding is really not our end game. It is our way onto the farm. What's really interesting is once we're on the farm, what else can it do, I think is the big question. And what else would you like to see and collect and analyze and understand? Somebody mentioned digital twin for the outdoors. So what you're seeing here is not a drone image, or it's not a satellite image. This heat map is what our robots were able to collect, our fleet of robots. This is 160 acres that about 4 to 5 of our robots were constantly roaming around and collecting data on a day-to-day basis, right, for the entire growing season. I think that's really different than something like drones, where you need to fly over, pull the SD card out, do post-processing, and all of that. This is actually happening on the fly, on the edge. Here's an example of what we're doing here. We're using stereo depth cameras to be able to see the crop as well. This is a new feature that we're building with the next generation of robots. So what this means is that not only can you see a 2D image of the crops growing, we can actually sense how tall each crop is on a day-to-day, hour-by-hour basis within a millimeter accuracy. And we think this is huge and has a potential to unlock other applications. And the difference between the blue dot and the green dot that you see here is that we're able to show and predict where the root of the stem of the plant is actually entering into the soil, which is pretty cool. And we need to do that because that's where our blades need to be able to strike. And the green dot is the top of the plant. So that's how we know the depth or the height of each crop. So on the left-hand side here is the data that I've shown you that are raw data that our robot is collecting. You could do things like predictive analytics that you see on the right-hand side of the map. In this case, it's weed pressure predictive analytics that we're detecting. So imagine being able to not only use the robots, but apply additional applications like sprays or fungicides with different applications. Then, of course, with the large language models, we're able to query this type of data from each robot and just start asking human questions in human language, right? Saying, hey, what did you see out there today? Like, what is the growth pattern? What are some of the trends? And it's able to spit that information out. Just very quickly, we're looking into other industries as well, not only food and ag. I think this could be super interesting. So one area that we're looking at is for humanitarian applications like demining. So there's mines that are happening that are being deployed across the world in times of conflict and war. And majority of these lands are agricultural lands, which is very unfortunate. So imagine if our robots can be deployed to detect and remove mines, and after it's clean from mines, our robots being able to help you also farm effectively. That's our vision that we have. We have an amazing team.
You have an amazing team and an amazing vision and an amazing running out of time. So we need to move.
Okay. Yeah.
Kenny, before I go to Lex and I ask him how we're going to put this in Wageningen, before I do that, allow me to bring to the table another company. My job here, our job, Helena, my job is to bring the corporate members of Optica in contact with you. So I'm going to go all the way to Switzerland. There is a company called Merceter, and it's represented today here by Raffaele Suri. Raffaele, thank you very much for being with us today. I think you have a question for Kenny.
Yes. Do you hear me?
Loud and clear.
Yes.
Okay, perfectly. We've worked on a project before that also had a weeding robot, and they used one of our LEDs because their system for weeding was based on destroying the weeds with a laser. And now I'm seeing your system. I'm curious to know how did you come to this design choice? And did you consider lasers at all, or did you see just a big an advantage in using your system?
Yeah, great question. We did explore with lasers. The challenge with lasers is that it's very power intensive. And so which essentially means that you do need a power source that is very high dense, like, fossil fuels. Trying to do that with only solar is a really huge challenge. I don't think we're there yet. But once we get very efficient, high-powered lasers, maybe some of you could solve that. We have about 70 to 90 watts available specifically for weeding. Everything else is dedicated toward navigation.
Thank you very much, Kenny. Please stay with us because we have a couple of questions for you. But before that, Rafaele, you make laser diode, laser drivers as well for industry applications. So allow me to say something here. Evangelos from Picoquan, now that you are targeting the industry applications, do you have already partners for laser drivers?
I mean, until now, for our applications, we're doing our drivers ourselves, but we are open to discuss, because for future needs, maybe we need to do different things. So we're open in discussions. And by the way,
that's the coolest part of my job. Evangelos, Rafaele, the two of you are going to have a discussion. And if you had to, Rafaele, you had to send some laser drivers to Picoquant, I pay for the shipping expenses. And I will not claim it to Optica. Allow me to bring the floor to the next question in the room. Let's go all the way to France. Antoine Fournier from Arvalis, what's on your mind?
Yeah, thank you, Jose. It's more an agronomical question about the efficiency of weeding and until which stage could you have an efficient in-row weeding? And are you bound to row sowing or more complex geometrical pattern in the field is compatible with your solution?
Yeah, right now we're targeting row crops. So as human eyes, you could see the rows, and so we could vary the widths of the robot. And in terms of development stage of the crop, so we're focusing on like soy, corn, soybeans, cotton, and sugar beets at first. And just because of it bound by the geometric shape, height, and width. And in terms of development stage of the crop, we're not limited by that. It's really development stage of the weed. We do not want to wait until the weed gets really tall. I don't know if you've seen tall weed; they could look like tree trunks. So really, we're we're deploying our robots as early as possible, and we're living out there the whole entire time. The best analogy is like a Roomba. You want to be out, you want to deploy a Roomba after the room is clean, and it'll keep it clean as long as possible. You don't want to be there when you got, clothes and everything just laying around really dirty. And it's been really successful. I think the unique advantage is that we can actually use the hoe to blade to actually strike down weeds and just rip it out. And we can go back and forth again and again until that area is kept clean.
Antoine, hold on, because you're going to be the next speaker. Before we give you a presentation, allow me to give the floor now back to Michel from Unilever. You have something very cool to ask.
Yeah, just broad question, Kenny. I'm not sure if you can already answer, but I was just curious here. You mentioned about affordability also, right? About keeping the system simple. How does this stack up? Because I know in foods growing as well as processing, it's quite an affordable system typically we have now, right? So any capital investment quickly can become a challenge. Are you overcoming that already, or is it still early days?
Yeah, no, good question. I can't answer for the global markets, but at least here for the US, human labor is really, really expensive. And even if they have the budget for human labor, it's just not available.
Yeah,
they're just not enough people to be able to support rural regions here in the US. People just don't live there or don't want to live there. And specifically for chemicals, we're not at parity of chemicals yet, but that is our actually mission, to be actually cheaper than chemistry. So we're making these robots as cost effective as possible. We're getting very, very close though. But the great application right now is areas where it's called weed herbicide resistance, where chemistry is not responding. Like we know, I think we all know about glyphosate or Roundup. That's the top chemicals that it's using in agriculture. There's plenty of weeds here in the US. You spray it and it does not die. And the only alternative to that is either mechanized way to remove it or human labor. And the mechanized way of currently using tractors, implements to remove it is not precise enough, because you need to get right up to the plant to be able to remove it. Or number two, again, labor does not exist or is too expensive in many parts here.
Makes sense. Thank you.
Kenny, we have a lot of questions for you, so I had to filter them. But one more thing is really cool. I want to go to Canada, to the Saskatchewan region, because the person, the food safety specialist from that region, which I don't want to pronounce again, from the Ministry of Agriculture of that region, has a question for you. Halil Sakhtaut, are you with us? Halil?
Halil from Saskatchewan.
If not, I will ask the question myself.
Yes.
I know he's with us.
Sure.
Halil.
Thank you.
Yeah, I have a question with those robots. Do you have issues with moisture content in soil, soil texture? Does it become less efficient under certain soil conditions? Stuff like that.
Yeah, a great question. Soil moisture, which you get enough of it, it's muddy. It's called mud. And we operate in some of the muddiest, clayest soils that we could ever find. We operate in Minnesota and North Dakota. It's called the Red River Valley region. And I think mud content is about like 98% is like mud or clay. Surprisingly, it does actually really effectively well. And it's how humans would actually do it. So again, we've tested in various conditions, all the way from California, all the way to, close to Canada borders. And
Kenny, how you tested it in the Saskatchewan region in Canada?
We have not, but
because the Ministry of Agriculture seems to be interested. Halil, I'll let you contact Kenny offline and we move on. Now, we have been to so many areas, from the Netherlands, we have been to Switzerland, we're having, of course, the US, Canada, now we go to France. Antoine Fournier, thank you very much for being with us today. Tell us about the leading agronomic R&D activities at Arvalis.
Thank you, Jose. Thank you, Elena, and all the Optica teams to allow me to join. I'm very happy to exchange about this subject because it's been 15 years that I'm the photonist with boots, that I work at Arvalis, Institut du Végétal, which is a agronomical applied research institute. We are aimed to provide objective and neutral scientific references about mostly everything is sell or buy to the French farmers of plain crops. I won't list them, but we are working also with our cousins, which is other technical institute, leading the same subject on beef, for example, on chicken or other different domain. Since 2018, I lead a partnership between Arvalis, Institut du Végétal, and Photonics Bretagne, which is a technical cluster in Brittany about photonics, and we promote the mobilization of the excellence of the photonics in terms of academical and industrial to allow the rise and emergence of affordable and performant agrophotonic solutions. So, so much thank you, Optica, to give more boost to this initiative again. First of all, I will go quickly about what are we talking about. Agrophotonics. Light can do a lot of things, but not everything in agricultural and in plant science. So let's go a little bit further. Photonics in agriculture. Photonics can serve directly in agricultural practices in terms of lighting, of disinfection, of destruction of plants, but also to make them grow or to drive the growing of different patterns or to facilitate different behave from the plants in very controlled environment like indoor or urban, semi-controlled like greenhouse or in a playing field. Photonics can be also very useful after the harvesting for better conservation, for traceability and allotment. It is very, very important and also a way to make progress in terms of weight reduction and food efficiency by having good care of allotment and at every stage of the logistic and retail chain. Photonics can also be a key advantage in different plant science and environmental science. It is also the best way to serve all the agricultures because only the highly technical in terms of agronomy, agronomically technical country can allowed to buy and to exploit high-tech photonics solution for the agricultural practices, but there is a lot of science field and domain around and in agronomy, and they all need to make progress in terms of instrumentation at the lab to have more detail, more information, more robust in the field, more objective, more prone to resist to different artifacts, and that have to be cheaper also to be integrated in large network of surveillance and to build up the data sets, the world data set and highly curated data sets that we collectively need to make some models and interpretation to emerge from our collective works. If you work in plant science, is also on the vicinity and the neighboring of environmental science, because if you are concerned by the health of the crop in the playing field, you are also to survey the insect and all the pathogens that can impact it. And photonics is also a key aspect for agrofurnitures. So having good tools to evaluate the impact of new cultivars, of new practices, of new equipments is a key, but this time in the day-to-day job of a technical institute and technical research like CIMIT or other CGIR that I recommend you to document about if you don't know who they are, because they do the work of herbalists, but at global stage. So they work not just only for the big countries, but also for everyone. The domain that historically work the most on the photonic sensors for plant science is plant phenotyping, and with the trends that I have 10 years now of high throughput plant phenotyping. And phenotyping is the phenotype is the expression of a genotype in an environment, including the agricultural practices. But this issue being well instrumented now, notably at Wageningen, we are collectively as a community going for precisely environment surveillance is going toward ecotyping, so the interaction between the plants, the crops, and the all living elements in his paysage. landscape. Genotype is going more and more toward metabolomics, so the expression of the physiological process in the plants and how they are derived. And phenotype is going more precisely into physiotyping, so the fast response and the different way of the plants to avoid local stress that are more and more present. If you want to contribute or have also already significant results, I encourage you to submit to Optica, obviously, but also to this publication of the American Society of Agronomy. I want to share with you some issue for the photonist to better understand how they add value of the value chain and how to go, what are the big issue to go to agrophotonics. First, we have to accept that there is a very, very vast diversity of use cases. You will speak each time with people with very different expectation by species, by outlets, even in the wheat, depending of what people make with the wheat, you will have very, very different people with very different expectation. And you also have different sensing environment at the different state of the agri-processing. If you multiply all those difference of waiting for the markets and try to address it with the different optical phenomena that we have in the pockets to try. You have an explosion of use cases that was quite well described by a good paper in Frontier in Plant Science by colleagues from Wageningen again. So we have to accept that there is a forest of micro use cases, and they all need a strong work in commercial adoption. Secondly, let's see the value chain of service by sensors in the farming sector or the phenotyping, so for the scientifics or for the farmers, will always have to integrate the performance of a sensor, of the carrier machine, also the performance and limitation of the mixed model, which is the instrumental model, the interpretation of numerical values in the chip, the digital chip, into a physical value. This is the metrology and photometry, which opticians are good with, but they have to feel and to be digested by agronomical models in order to have significant and applicative insight and traits to give advice on decision support tools for the agriculture, or to give objective information and documented information for the progression of the knowledge of what happened at field. So there is a loop between the applicative model, the operational usage needs, and the technological development. And if each one is waiting for the other, it is a broken loop. And we will try to enhance those links. If to be more concrete, I take the example of spectral imaging. The market of spectral imaging is highly atomized. You have a lot of small applicative markets, very low volume for each one, in different domains, with complex value chain by domain. So it's quite similar, but agriculture is worse. And you have an imbalance between a few big players like SIM or Edwall, and a lot of numerous specialists with very impactful and very specialized comprehension and offer. And each one have its place. But for conventional innovation models and business models, it could be very difficult because you are fast evolving techniques, so you are never on full securized about the emergence of new component methods or softwares. you need highly specialized expertise on your bricks, but also on the neighboring bricks of the value chain in order to penetrate and have impactful commercial discourse. Your users will have a turnover of the use cases, because when a user in the agronomical world came to something important, it is something important for the last harvest or for this year, and not for the next 5 or 10 years, which is the time you will need to have a complex and comprehensive product. And most of your value is still in the data. So my opinion and my analysis on that is one private actor won't bring something agile enough and something affordable enough if we want to tackle the different issues and challenges that the agriculture are facing. For example, in spectral, you have big data in terms of volume, so it makes time to analyze, it makes time to load. So there is very few big, fair, accessible and useful spectral database in order to make emerge new models. And the sensors are expensive. So the model will be expensive also. How can we deal with that? We try with a spin-off from the Partenariat Agro-Photonics, which is Photonics Open Project. We found it in 2023, and try to reverse this drawback by a logic of community, of making it open. So we have an open source development kit that everyone can build itself with spectrometers from different producers in the optical community, and develop models, be used to the techniques, having open the black box and understand what happens in advanced non-conventional imaging techniques, and develop their own models, method, and functionality, can share or not with the communities, and after apply them on an industrial version that the company POP will help the industrial to maintain and to have a continuity and durability of the technological solution.
Antoine, many thanks. We are actually, I mean, it's a little bit on this a little bit long, but yeah.
Can I
so
conclude?
so let's wrap it up. So one of the things that is important here is like okay, when integrating the spectral data across the platforms, okay. So how to manage the spatial temporal resolution, and the other thing is, one of the things that we were talking before is the scaling in the agriculture industry is quite different, because it will depend on the crop and all the things. So can you give me a little bit on this take message?
If I understand, how do we manage the diversity of scene and on question in the fostering databases?
Yeah.
Okay, this is the point of having a community management of the emergence of database, because when you talk with people that making that in the field, really they are not the same people. So if we want to have some flax, wheat, or maize scene, we will need to embody people from the different cultures, and also we can push it to the different area of production, and so the emergence of actionable models will come from comprehensive data set, and data set will come by transparency between the actors and the adoption of common usage. That's why we think and I encourage the application of fair standards also within industrials between us. It's not the use, but we won't tackle the agricultural and environmental issues without sharing the practices. I don't mean to share the value, but the practices.
Okay, yeah. So we have a question from the audience, but I want to move forward first to Drew Ray from Mozambique. This is one of the coolest technologies I can see, because it's a solution to create all this meat in the lab. So that's going to decrease the resources that are needed for animal protein. So Mosa, Drew, the attention is all yours.
Thank you very much. Quickly share my screen. Right, so I'll just quickly begin. My name is Dhruv. Thank you very much for inviting me. I'm very happy to talk to people and introduce the idea of cultivated meat, something that I believe very strongly in. So I lead a team of cell biologists that is trying to solve the problem of cultivated meat. And, you know, cultivated meat is a really difficult problem to solve because it has all of these different layers to it. So, for example, one of the layers is it's a complicated scientific challenge. You know, this is the thing that drew me here in the first place, speaking as a biologist. But as anyone here who's been on a scale-up journey also knows, it's a very complicated engineering challenge because we have to figure out how to translate bench scale findings, you know, often at the 5 milliliter to tens of milliliter range, all the way up to the hundreds of liters, potentially the thousands of liters. And that correspondence is really not clear. It's also a business challenge in some sense, because I think the cultivated meat sector needs to finalize on a business model that ensures profitability and sustained growth. And finally, from a consumer perspective, I think just the idea of cultivated meat really makes you really confront questions about what is the source of the food that we consume on a daily basis. So what I thought I'd do today is I'll tell you a little bit about what the process of cultivated meat looks like, sort of speaking generally, and then I'll zoom in on one or two tiny problems that, well, big problems, but I think we're getting close to the solutions that the cultivated meat industry is struggling with at the moment. So I moved to Europe about 10 years ago, and I have to say, since moving here, I've only seen more and more of my friends and colleagues choose to be vegetarian or vegan or flexitarian. Despite this wealth of anecdotal evidence, if you look at the hard data, you will see that the per capita meat consumption in the EU has absolutely skyrocketed in the last 60 years. So each person consumes between 60 and 80 kilos of meat per year. Now, if you try to extrapolate this to the rest of the world, and you say, hey, what if every person decided it's my right to consume this much meat? Well, then our crumbling food system will just totally collapse. We know it can't sustain it. And a big part of the reason why it can't sustain it is because meat consumption comes at an extremely high environmental price that we often don't really talk about or think about. So here's some, I would say, frankly, very shocking statistics. Over about 80% of the agricultural land that is currently in use is either used directly for livestock farming or indirectly, which is to say by growing crops that ultimately supply the feedstock. Most of the antibiotics that are used globally are actually used in the cultivated meat, they're used in the livestock sector. So when people, you know, say doctors are overprescribing antibiotics, perhaps they are, but my suspicion is that this is probably a bigger source of this problem. If you try to do the, you know, admittedly very fraught exercise of trying to calculate greenhouse gas emissions, here too, you will see that no matter how you slice this pie, the consumption of meat has a significant impact on the environment. So all of these questions led us to the question, can we actually redesign our systems of meat production to be somehow more sustainable? The idea we had was the idea of cultivated meat. We're not the only players here, but in our process, what we do is we start with a small biopsy from a cow. This is either a muscle or a fat biopsy. Other companies that also use embryonic stem cells or induced pluripotent stem cells. So you need some kind of initial starting cell material. We typically start with a 1 gram biopsy sample. Somebody takes this biopsy sample, then they drive it back to the lab really quickly. We bring it inside the lab, we chop it up, we digest it with some enzymes, and then we sort the cells based on antibody staining and some tags that we put on the cells. we sort them into muscle and fat progenitor cells. Now, these two types of progenitor cells, we then grow up separately in our serum-free medium. I said we start with a 1 gram sample of biopsy. You may be asking, well, fine, 1 gram, that sounds like an interesting research experiment. What can you actually commercialize with that? Well, the thing is, because every time a cell doubles, well, it doubles. So you go from 2 to 4, 8, 16, 32, etc. You have this geometrical expansion. If you look at this cartoon down here, you see that a 1 gram sample, we could theoretically get something like 10,000 kilos of meat in 35 population doublings, which is a completely normal and expected number of cell doublings to get. Okay, that's quite cool. So we can actually generate a large mass of product, but where do we grow it? Because you think 10,000 kilos of meat is going to require a lot of space. The first time we did this, which was in 2013, the first burger that was ever made, cultivated meat burger, it was something like 250,000 euros to produce at the time. We used giant tea flasks. Anyone who's worked on tissue culture knows what a tea flask is. But so we use these very special cell factories or hyper flasks. And all of this is required to make one burger. Now, obviously, that's not what we want to do. We don't want to replace cows in the field with giant walls of plastic. So we need a more sustainable way moving forward. And so what we do is we grow the cells in big steel vessels called bioreactors, that I'm sure you're all very familiar with. The bioreactors, we can either grow the cells on microcarriers, which are tiny beads. We can grow them as aggregates, or we can grow them in suspension. And here I'm showing you a 3D reconstruction of a confocal image that I made when I first joined the company about 4 or 5 years ago now. And what you're looking at in purple is the nascent myotubes. So you're seeing tiny, like, let's say, pre-muscle fibers sort of forming, wrapping around these beads, and they're floating inside the bioreactor. Now, this process by which satellite cells or muscle progenitor cells fuse to form myotubes is called myogenesis. And this is roughly what the process looks like. But because it's a photonics conference, I thought it might be a cool idea to show you some really interesting movies. So this is a movie that I acquired on a quantitative phase imaging microscope. So this is a totally label-free microscopy technique that uses differences in phases to generate contrast. This is extremely sped up, but what you're looking at here is the formation of these fibers. And as the fibers thicken, then we can also see that there's more protein accumulation. So in addition to muscle, we can also do the same process with fat. What you see here is conventional fat in the middle, and what you see on the right-hand side is the cultivated fat that we produce in our facility, which sort of looks similar macroscopically as well as microscopically. And if we look at the fatty acid profile, we see it also matches conventional fat a lot more closely than, for example, coconut oil. And this, we think, has an impact on the taste profile, which we've also sort of validated through internal taste testings and taste testings with external agencies. Okay. So that's how we do cultivated meat. And in the last couple of minutes, I'll tell you about 2 of the big problems that the industry faces. One is the use of animal components, because the whole point of this is that we want to get animals out of the food chain. Seems pretty backwards to now reintroduce animal components. So one of the big issues with cell culture medium for a long time has been the use of fetal bovine serum. We've got here, I've linked 3 papers that our team has published here at Mosa Meat, where we figured out how to get rid of the serum from the medium. We've also now working on getting rid of even more animal components, because it's sensible for us, because it makes our process cheaper, it makes it more reliable, makes it more defined, as well as it's more friendly from a regulatory perspective. So we have lots of incentive to try to develop this further. And the second issue is the issue of costs. Now, I started by telling you the first burger we ever made was 250,000 euros, and that's true. And you may ask, well, why was it so damn expensive? There are a couple of reasons. One is, of course, the plasticware and so on, but also the raw materials that we used. So we currently have to use pharmaceutical grade ingredients. What I show you here is a screenshot from the local supermarket chain here in the Netherlands. This is 1 kilo of sugar for 93 cents, whereas if you go to the Sigma website where we buy, our chemical reagents, it's 128 euros. You can see there's orders of magnitude difference here in the prices. A lot of this is because this is the only grade that's available to us. Some of it is because at this stage in our development, we really want to use the highest purity ingredients so that our scientific findings are robust and reproducible. This means that in the long run, we're a little bit more efficient with our R&D. Our long-term vision is, of course, to replace as much of this as possible with more reasonably priced ingredients that are at the food or feed grade level, which is what we think can really sustain this process. Another thing that we do quite a lot of is to share as much knowledge as we can. This is because we're still a very young company. The cultivated meat sector is quite young, and I think it benefits everyone to share as much knowledge as possible. So we very frequently publish. This is also one of the reasons I really love working here. And with one slide where you can see some examples of other cultivated meat products that various companies are in the process of trying to make. Thank you.
Look, the question everyone has in mind, because we have a lot of money in the photonics industry, we can buy the burger. Does it taste well?
Yes. So I've been on the tasting panel. I've tasted early versions of the product and more recent versions. The earliest version I haven't tasted because I wasn't there, but I was told it didn't taste very good because we hadn't cracked the fact that we need fat for the flavor. The versions that we have today, they taste identical to just regular meat. We've had chefs taste them, we've had professional tasters test them, and in each instance, people are able to very clearly identify that this is a cultivated meat burger because it tastes so much richer and so much more like regular meat than a conventional plant-based burger.
I offer myself as a volunteer to taste the burger next time that we see each other. But in addition, what can we do to help you? We have here the entire industry for companies that make sensors, camera detectors, equipment manufacturers like XMTech in the room. How can we help you?
Well, I think one of the challenges we currently have is really online monitoring of how the cells are doing within our bioreactors. I think it's a very difficult problem to solve. We have things like impedance probes, for example, to just measure whether the cells are alive. You can correlate an impedance measurement with a viable cell density. But this sometimes works, other times doesn't work super well. We have optical probes for things like, DO, dissolved oxygen, pH, and those work quite well. But we still don't really have a good way of saying, are these cells healthy or not? By the time we start seeing drops in our doubling times, it's already too late for an intervention. So we need something that can almost predict when the cells are about to start crashing.
Dhruv, a lot of people have smiled, and if the meeting lasted for 1 hour, I would make a round of people who can help you for the online monitoring. But if we cannot, remember that everybody who enters the room and everybody who registered for this meeting is going to have the opportunity to be introduced by email to Dhruv Raina. Your inbox is going to be quite busy in the next hours. But allow me to introduce you one company who perhaps can help you. Even though the initial business plan is on milk, they could have a solution for you. I would like to welcome to the room our corporate member representing our association today, the company Labi, Julia Sommerden. We always save the best for the last. You are the best today. Show your slide and send us home the way that we are supposed to. The floor and the attention of everyone is yours.
Thank you, Jose. Let me share my slides here. Give me 1 second.
Julia is one of the success stories of the Luminate program, the most important accelerator in optics and photonics from Rochester, New York. And she graduated from the accelerator last year with great marks. Now we can see your slide. Show us, please, what you do.
Very good. So I'm going to show I'm drinking milk. This is real protein. Tastes good. It's nutritious. Again, good morning, everyone. My name is Julia Sommerden. Thanks to Optica to give me this opportunity to share our work at the intersection of optical innovation and legacy industry, which is dairy. So Labi is based in Rochester, New York, which is hometown for Xerox and Kodak. So at Labi, we developed we transformed their industry by delivering real-time inline milk testing solution and providing dairy producers with data-driven insights on animal health, milk quality, and compliance. As everyone knows, milk testing is a critical function for the industry because of food safety. However, as everyone, Unilever even mentioned, the industry still rely on century-old lab-based testing. So today, farmer had to wait for 4 to 6 weeks before they can get technician get on their farm to do testing. So farmer, as a result, farmer lose money every day. A single infection could contaminate the whole bulk tank. Farmer lose $1,000 from spoiled milk, penalties, and lost productions. So that's where we come in. We change that. Our patented optical sensor, image sensor, can detect milk under 15 seconds. With that data, farmers can detect sick cows before the contamination spreads. As a result, farmer can save about 30% on antibiotics cost and save about $500 per cow per year. So our solution has basically 3 modules: hardware, sensors that can capture optical signal from the milk directly and provide milk quality information on butterfat, protein, and the somatic cell count, which is a direct indicator for mastitis. That information will transmit to the cloud real time, and from there, our AI engine provide milk results, testing results. So that data is accessible by anyone who has access to the portal. The big potential is here. We start from animal health, but we want to become the milk compliance testing platform. So our data provide the first mile milk quality intelligence as the point of origin. With that information, we could potentially transform the whole dairy supply chain from farms all the way to dairy processors and retailers. That's the end of my slides. I just had about 2 minutes. Thank you.
Thank you very much for that. Julia, how can we help you?
So we're looking for, as I say, now we're looking to brand from the farm out to the whole supply chain, right? To not only we have inline sensing for dairy farmers, we do have a portable device as well that can expand into different applications. So we're looking for different application suggestions and where we can leverage our technology and the product.
Julia, thank you very much.
And protein testing for the food. Thank you.
Many people are going to be reaching out to you. We want you to be successful. Thank you for being a corporate member of Optica. And thank you, everyone, for a fantastic, I was going to say 90, but I have to apologize, 102 minutes of your time. Okay, allow me first to ask IT department to disconnect the YouTube. So please disconnect the YouTube. It's disconnecting now. Thank you very